So let's do an example of finding an equilibrium vector. So say we have some transition matrix, 0.6, 0.4, 0.4, 0.6. Okay, and just for kicks, let's say, let's use the example from the book that keeps showing up about the dry cleaners. So there's Johnson Dry Cleaners and North Clean. And by definition, if we've got this equilibrium vector times the transition matrix will give the equilibrium vector. So basically what the equilibrium vector is telling you is, in the long run, what proportion of people are going to Johnson and which proportion are going to North Clean. So to do the calculation, so we want to find this, vector when multiplied by transition matrix gives us the equilibrium vector. So doing our multiplication, we've got, the first row times the first column gives us 0.6 V1 plus 0.4 V2 equals that first element, and then the first row times the second column will give us V1 times 0.4 plus V2 times 0.6 equals V2. Now, if we want to put this into a system that we recognize, this first equation, we can subtract V1 on both sides to get negative 0.4 V1 plus 0.4 V2 equals 0. And for the second one, we can subtract V2 on both sides and get 0.4 V1 minus 0.4 V2 equals 0. Now what we can see with these two equations, they're the same basically. If I multiply one of them by negative 1, I get the other equation. So if I multiply the top by negative 1, I get 0.4 V1 minus 0.4 V2 equals 0. If I multiply the bottom by negative 1, I get the top equation, negative 0.4 V1 plus 0.4 V2 equals 0. So this is a dependent system, so we need another equation to solve a system of equations. Well, we know in this probability vector, V1 and V2 add up to equal 1. So any probability vector, the sum of the elements of the probability vector will equal 1. All right, so what we can do is say, I'm going to take these two equations and I'm going to solve this system for V1 and for V2. So a couple ways we can do this. We could just use algebra. So I'm going to multiply the bottom equation by negative 0.4 and add that to the first equation. I got 0.4 V1 minus 0.4 V2 equals 0. When I add these two equations together, I get negative 0.8 V2 equals negative 0.4. Divide by both sides by negative 0.8, and we get V2 equals 0.5. Now if V2 equals 0.5, and we know V1 plus V2 adds up to equal 1, well, V1 is just 0.5. B1 equals 0.5 as well. So, given this transition matrix, it appears as if in the long run, 50% of customers will be going to Johnson and 50% will be going to North Clean. Now, a second way we can solve this would be using our calculators. So I'm going to bring up the calculator. So again, this is the TI-83. So what I can do is go into matrix. I can edit matrix A. So it's going to be a 2, enter, 3, enter, 2 by 3 matrix. First equation is 0.4, enter, negative 0.4, enter, 0. Second equation, 1, 1, 1. And then I can do matrix math. So I scroll to the math column. So I go down to this RREF, which is row reduced echelon form. And I want the row reduced echelon form of matrix A. And I get 1, 0.5, 0, 1.5, which means V1 equals 0.5, V2 equals 0.5. And that's an equilibrium vector.